Today we're going to begin our lessons on transformations. There are 4 transformations that we'll be learning. The first one is called a translation. So these are just basically moving shapes in a coordinate plane. And there are 4 types of ways that you can move those shapes. The first is the most basic. It's the translation. It's really, we're just, sliding the shape around. So if we go to the right, we're going to add to the x part of each point. Each ordered pair has an x and a y, so we'll add to the x if we're going to the right. We'll subtract from the x if we're going to the left. We'll add to the y if we go up and subtract if we go down. So here we have this shape right here. It's a trapezoid. And we're going to do a translation of this shape. So in other words, we're going to slide it to a new position on our coordinate plane. So the directions right here say to translate, which means slide it or just move it, 3 units to the right and 4 units down. So let us start by putting the ordered pairs in our table right here. So let's start with D. So point D is 1, 2, 3, and -1. E, I'll just go alphabetical, is -3 and 1, 2, 3, 4, +4. Oh, whoops, I forgot to put a negative there. That's -3, -1. This one's -3, +4. F is -1 and up 3, and G is -1 and 0. So because we're going to be going 3 units to the right, we're going to take our x term and add 3. And because we're going down 4 units, we're going to take our y term and subtract 4. So we're going to the right 3 and down 4. So we're going to add 3 to our x's and take 4 away from our y's. So that means that we're going to have -3 plus, oh goodness, -3 plus 3, and we'll have -1 minus 4. So our new point is going to be 0, -5. So I took the -3 from the x value of our first ordered pair and added 3 because we're sliding it to the right, and I got 0. And then I took the -1, which is the y value from our ordered pair, and I subtracted 4 from -1 because we're going down 4, and that becomes -5. So eventually this middle step's not going to be so important. Like, you're probably not going to want to write it every single time, but I'm going to do it just so you know where I'm getting these from. So -3 plus 3, and then 4 minus 4 is going to give me 0, 0. Then I have -1 plus 3 and 3 minus 4 to give me 2, -1, and lastly -1 plus 3 and 0 minus 4. So I'm going to get 2 and -4. Those are, right here we have the points of our new shape. So these little like apostrophe looking things, I've always said those as like D prime, E prime, F prime, G prime. It's like the new points of the new translated shape. Let's draw it. Let's use a different color, and I'm going to draw these points. So I have 0, -5, 1, 2, 3, 4, 5. I have 0, 0. I have 2, -1, and I have 2, -4. So it should be the same shape, the same size. It's just 3 units to the right and 4 units down. So you should be able to count from this to this, and it should be 3 to the right and 4 down. So we've drawn our new shape, and we have new ordered pairs. And each ordered pair is 3 to the right and down 4. So that is translations. The next thing we're going to learn is reflections. And it's exactly what it sounds like. It's like we are flipping our shape over. And there are 2 ways that we can flip it that we're going to learn about. Of course, you can flip it over any line on your coordinate plane, but we're just going to learn about flipping it across the x-axis and the y-axis. So when we flip it across the x-axis, we're going to keep x the same and do the opposite of y for our new ordered pairs. And when we flip over the y-axis, we keep y the same and we do the opposite of x. So there's an easy way to remember that. Obviously, you probably already thought that when we're flipping it over the x-axis, the x stays the same. And when we flip it over the y-axis, the y stays the same. So here we have our original triangle here, triangle JKL, and it has points, right? So let's write down our original points first. So J is negative 1, 2, 3, 4. So it's negative 4, positive 2. K is positive 2, positive 4. And L is 3, 1. Okay, now the first directions here say to flip it across the x-axis. Well, it says reflect. Reflecting is flipping, but the better way to say it is reflect. So since we're reflecting it over the x-axis, our x is going to stay the same, and we're going to do the opposite of y. So it's going to be the same x and the opposite of the y. The same x, the opposite of the y. The same x, the opposite of the y. Now, if y was a negative, none of these are, but if y was a negative, you would flip it and make it a positive. Like you're just doing the opposite of it. You're not making it negative, you're doing the opposite. So if it's already negative, then you'll make it positive. So I'm basically just writing those exact same things here. So let's graph the new shape. It's going to be negative 4, negative 2, 1, 2, right there. Then we have 2, negative 4 is here. And then 3, negative 1 is here. 1, 2, 3, negative 1. All right, now if we were able to somehow bend this screen along the x-axis, those shapes would perfectly line up if we could fold that graph in half along the x-axis. So you can see it is a true reflection. Let's try doing a reflection across the y-axis. So first we're going to write the points of our pentagon, starting with M is 0, 1. N is 1, 2, 3, 1, 2, 3, 4, 3, 4. P is 6 and 1. Q is 5 and negative 2. Whoops, got the negative. And R is 1 and negative 2. So if we're rotating or we're reflecting it over the y-axis, we're going to keep y the same and do the opposite of x. So we're going to do opposite of x and y. The opposite of 0 is just 0. The opposite of x, keep the y. The opposite of x, keep the y. Opposite of x, keep the y. Opposite of x, keep the y. And then I'm going to graph that new shape in a new color. So I have 0, 1. I have negative 3, positive 4. 1, 2, 3, 1, 2, 3, 4. I have negative 6 and 1. I have negative 5, negative 2. And I have negative 1, negative 2. Let's connect those to make my new pentagon. And you can see that if I reflected it over the y-axis, it would be a perfect reflection. It would be like overlapping. So that is translations and reflections on the coordinate plane. Thanks for watching.